Hey, welcome to topic number 11, order of operation with fractions and mixed numbers. So let's do some order operations with fraction first. So just real quick, recall the first level of order operation. Okay, if I have parenthesis, bracket, and brace, I always have to do what's inside the parentheses first, right? Because brace is bigger than brackets, which is, oh, bracket is bigger than parentheses. So either way, we have to work from inside out. Okay, but I don't think I got any brace here. In my examples. All right, anything involving with exponents, that's a second level. Multiplication or division, always do it from left to the right accordingly. Doesn't matter is division come first, then multiplication. We just do multiplication or division. Okay, from left to right. So we mentioned that addition or subtraction here is the lowest level. These are referring to the addition and subtraction outside the parentheses. So just a quick hint about multiplying operation of fractions. When we multiply a fraction, remember we got to reduce before we can what multiply. When dividing fractions, we got to times the reciprocal. Okay, first, then we're gonna reduce the fraction once we make the problem become multiplication of fractions. All right. When add or subtract fractions, remember the first thing is find the LCD. So we've been using, we've been looking at addition and subtraction signs outside the parentheses to help us separate the problems. We did that with the whole numbers of order operation. We're going to do the same thing here for the fractions. So in this problem, I see there is one addition outside the parentheses. Okay, so what's in front of it, this multiplication of fractions goes together, and what's behind it, the division of fraction goes together. So I'm going to work on them separately, okay? I'm going to work on them separately. And I'm going to fill in my addition sign here. So 3 over 5 times 1 over 6. This is multiplication of two fractions. So we will reduce the top with the bottom first before we multiply. So I see the top 3, bottom 6 can be reduced by 3. So that gives me 1 and 2. All right, so the top is only 1 now. Cannot reduce with 5 and 2. So my first one I highlight in yellow will be 1 over 10. So I'm going to put 1 over 10 right here. Plus, okay, I'm going to take this division here on the side. 1 over 5 divided by 2 means divided by 2 over 1. So when it comes to dividing fractions, we will say times the reciprocal. So the 2 over 1 got to be flipped. The first fraction stays the same. All right, so there's nothing to reduce is 1 over 10. All right, so what coming out of the blue is 1 over 10. So now if you look at this problem now becomes addition of two fractions, right? So the denominator is already the same, so I can go ahead and add the numerator, which is 2 over 10. All right, reduce. This can be reduced by 2. So my final answer should be 1 over 5. Okay. All right, I'll try another example. So again, I see there's an addition right here outside the parentheses. So I'm going to use that to separate my problems. What's in front of the addition is dividing two fractions. What's behind the addition sign is multiplying two fractions. All right, so I'm going to take this division out here. 5 over 6 divided by 1 over 10. Division of a fraction means times the reciprocal. So the 1 over 10 got to be flipped into 10 over 1. 5 over 6 stays the same. All right, so once it becomes multiplying two fractions, I can reduce the top number with the bottom. So it looks like 10 and 6 can be reduced by 2. That's 3 and 5. So 5 times 5 is 25 over 3 times 1 is 3. Okay, so that's what coming out of the yellow. Plus, right? Addition sign is right here, plus. All right, 2 over 3 times 3 over 4. Reduce top with the bottom because this is already multiplying two fractions. So 3 and 3 can be reduced by 3. That'll give me 1 and 1. 2 and 4 can be reduced by 2. That's 1 and 2. So if I multiply them side by side, that will give me 1 over 2. All right, so again, this problem now becomes addition of two fractions. So adding two fractions, the first thing we do is find the LCD. All right, the LCD between 3 and 2 got to be 6. And I don't think the instruction says convert to mixed number. So your answer, just make sure you reduce them, okay? You don't have to convert into a mixed number if it's an improper. All right, the denominator 3 become the new LCD, got to multiply by 2 times, the numerator times by 2, that give me 50. Denominator 2 become the new LCD times by 3, numerator times by 3, that's 3. So this is going to be 53 over 6. And I don't think you can reduce it because only way to reduce the 6 is using 2, 3, or 6. And 2, 3, or 6 cannot go to 53. So that's it. All right, this problem right here, you see there's a subtraction sign outside the parenthesis. So what's in front of it is only a 7. There's no operation there. What's behind it is a dividing two fractions. So I'm going to keep my 7 minus the same. Let's figure out what the blue come out to be. Divided by 8 means a over 1. Division of a fraction means times the reciprocal. So that's 1 over 8. Gotta flip it. First fraction stays the same. So it looks like 2 and 8 can be reduced. Right? Now multiplying two fractions, so I gotta reduce first. So that gives me a 1 and 4. All right, the numerator is gonna be 1 over. Denominator look like 13 times 4. I think it's 52, right? Okay, so remember when we learned how to add and subtract fractions, I mentioned that we can use that trick. Whenever we are adding or subtracting a whole number with a fraction, we can use that trick like we did with the mixed number, where we take the denominator times the whole number. And then in this case, since this is a subtraction, we will subtract the numerator 1. So let's see what 52 times 7 is. Because my LCD is going to be 52. So 52 times 7, 7 times 2 is 14, carry 1. 7 times 5 is 35, plus 1 is 36. So this should be 364, right? Minus the 1. That will be 363 over 52. So 363 is really a big number, okay? But it turns out I know 3 can go into it. So what am I thinking 3? When I am dealing with larger numbers, I'm always using prime factorization first, okay? I know 2 cannot go into 363, so I'm going to say 3. I know 3 can because 3 plus 6 is 9. 9 plus 3 is 12. So by the divisibility by 3, 3 can go into this. Okay. Oh, hold on a minute. 3 cannot go into 52. I thought you could. No, 3 cannot go into 52. Oh, darn it. I don't think this can be reduced. Well, we would leave it like that. I don't think this can be reduced. Because 52 is a very weird number. Because, I'm looking at 52 because 52 is a lot smaller. Because what times what is 52? I know 52 is 1 times 52 and 2 times 27. Right? I know 3 cannot go into it. I know 4 cannot. So I'm running out a lot of numbers that can go into 52. 3 going to 52 2 times. Oh no. 52. 4. Oh, I'm sorry. It's 26. Sorry about that. All right, 26. Sorry. So when I roll this 26, in my mind, I know 26 is also broken down as 2 times what? 2 times 13. Okay, so a little bit of prime factorization is coming in here now. Okay, I'm using a combination of both techniques. All right, so this 26 So that means I know 3 cannot go into it because right now you haven't seen any factor of 3. But I do see 4. 2 times 2 is 4. So that tells me 4 can go into 52. Thirteen times. You see how I wrote the 13 right there? Okay, so that's probably it. Okay, that's probably it. So what are the choices I have to actually trying to reduce 52 with? I have a choice of 2, 4, and 13. So 13 can go into it. So the question now is, I know 2 or 4 cannot go into 363. So the only other choice I have is 13. Can 13 go into 363? Well, 13 going into 36 is 2 times, which give me 26. 3 times will be 39. So that's a 10, right? Bring down the 3. So now I'm asking myself, okay, 3 times what number? What ends with the 3? Because right here, I want to go in evenly. So 3 times what number ends with the 3? 3 times 1 is 3, okay? But on the timetable, 3 times no other number ends with a 3. Okay, so cannot use it. So that tells me that 13 cannot go into it. All right, so we can leave on answer as 363 over 52. So when it gets to larger numbers, you really got to use different combination of techniques, divisibilities, prime factorizations, to figure out what are the good, what are good numbers that we can reduce with. Okay, that's the process of thinking. A lot, that we are trying to teach here in all of this class. All right, let's do some order operation with mixed numbers. Okay, remember now, multiplying, dividing mixed numbers, the first step is convert into improper fraction. Okay, and then we either reduce before we multiply, or we got to say times the reciprocal. Now, adding or subtracting mixed numbers was a little bit tricky. Okay, remember in the previous video when we add mixed numbers. Okay, after we add up the numerators, after we add up the numerators, if that fraction part becomes an improper fraction, then we have to convert that improper fraction into a mixed number. So we're adding more whole number. And subtraction of mixed numbers sometimes require borrowing. Okay, so it's a little bit tricky. So let's work on this. Okay, same technique. I'm gonna find my addition and subtraction signs outside the parentheses to split up my problem. There's one subtraction sign here. There's one addition sign here. So what's in front of subtraction sign is 5 over 8. There's no operation to do. All right, from the subtraction to the addition is multiplication of two fractions. Behind the addition is simply a mixed number, so there's no operation to do. So the only thing I need to focus on right now is the blue part, multiplication. 1/3 times 2 over 5. Multiplying two fractions, we're going to reduce top with the bottom number. But the 1 and 2 cannot reduce with 3 and 5. So what come out of the blue should be 2 over 15. Subtraction sign still there, plus sign still there. 5a is the very front. 6 over 6 and 1/10 is actually on the back. So right now, what we are looking at here is add and subtract with fractions along with mixed numbers. All right, so we're going to do them all together. Okay, I'm going to do them all together. So adding and subtracting mixed numbers or fractions, we got to find LCD first. So we need to look for the LCD between all three fractions. So 8, 15, 10. There's not one number can go into all three of these other than 1. So now let's look at 2 of these numbers at a time. Any 2 number. Okay, find me a number out here that can go into any 2 of these. If I choose 2, 2 can go into 8 and 10. If I choose 5, it can go into 15 and 10. So I'm gonna use 5 first. 5 cannot go into 8, copy it down. 5 go into 15 3 times. 5 go into 10 2 times. Okay, let's look at these three numbers, 8, 3, and 2. I mean, one number out here can go into any two of these, which is 2. 2 go into 8 4 times. 2 cannot go into 3, copy it down. 2 go into 2 1 time. So now let's look at 4, 3, and 1. There's not one number that can go into any two of these. Okay, so in that case, we can stop it here. When you go into 2 at a time, if you cannot find one number to go into any two numbers, then you can stop. So multiply all the numbers on the outside. So to me, it looked like 5 times 2 is 10. 4 times 3 is 12. 10 times 12 is 120. Okay, so my LCD here is 120. Ooh, big numbers. Plus 6 and something 120. Okay, have no fear. So if you wonder, okay, 8 will go into 120 how many times? Okay, so without doing too much computation, I wrote this out right here so we can see. Do y'all see 8? Do y'all see an 8? 4 times 2 is 8, right? So 8 will go into 120 15 times. See, only, so 8 is right here, so that means with 5 times 3, which is 15. Numerator times by 15. 5 times 5 is 75. 5 times 5 is 25. Carry 2. 5 times 1 is 5 plus 2 is 7. Okay. 15 will go into 128 times. See right here? I already did 8 times 5, so this is 15 times 8. Numerator times by 8 is 16. 10 will go into 120. See the 10 right here? 5 times 2 is 10, right? 10 will go into 120 how many times? 12 times. So numerator times by 12, which is 12. So now this problem, so let's handle our numerator. 75 minus 16. 75 minus 16. All right, that's 9. That's 5 plus 12. So that would be 71. Okay. So this problem now becomes 6. Now remember now I have a whole number, okay? 6 and 71 over 120. There you go. That's the answer. All right. I'll try to move this thing. Well, maybe I should. I'll tell you what, I'm going to just copy it down here. Let's have a little more space. All right, let's try another one. I'm looking for addition and subtraction signs outside the parentheses. See this addition sign right here? Right? Only one sign, so what's in front of it? Here I got multiplication of mixed number, then a division. Okay. All right, 5 over 9. Behind the plus sign, there's only 5 over 9. There's no operation. So let's work on this big old thing. So a lot of students say, okay, we do 2 at a time. Well, I'm going to show you how I can do all these together. Remember, multiplication of mixed number, we have to convert them into improper fraction, right? So basically, the idea is multiplying these two mixed numbers and divided by a over 3. So remember, a was 13. Remember, division of a fraction simply means times a reciprocal. Okay, so that means I can go ahead and say, oh, that is really multiplication of 13 over 8. All right, convert my first mixed number into improper. That would be 13 over 6 times 15 times 1 plus 1 is 16 over 15. Okay, I can go ahead and do that. All right, so now, ooh, this is nasty because there's some big numbers here. So it looks like 8 and 16 can be reduced by 8. That will be 1 and 2. 2 and 6 can be reduced into 1 and 3. So my top is now 13 times 1 times 13, which is 169 over 3 times 15 is 45. Okay. The reason why I know 13 times 13 is 169 because I already memorized them. You can work it out. So now that's what's come out of yellow plus the 5 over 9. So the LCD between 45 and 9 got to be 45. So the denominator 45 to become the new numerator times by 1. So my 169 stays up front. 9 going to 45 5 times. The numerator times by 5, which is 25. So this is 169 plus 25. All right, 14. This is 8, 9. This is 1. So this is going to be 194 over 45. So you say, okay, Mr. Chen, how do I reduce such a big number? Well, pick the one that's easy. 45. 45 we know is normally 9 times 5, right? And to break down the 9, so this is me talking about prime factorization. 9 is also 3 times 3. Okay, so that means we can also choose 3 to help us. So if you use divisibility by 3, 1 plus 9 is 10. 10 plus 4 is 14. 3 cannot go into it, so 3 is out. You know 5 cannot go into 194 because it does not end in what? 0 or 5, so 5 is out. 9 going to 194. That's the only thing I'm going to try. 9 going to 19 already 2 times, so this is going to be 14. 9 does not go into 14 evenly, so that's out. All right, so my answer, 194 over 45. Okay, so this problem here, this example here has parentheses and some exponents. So basically, here we need to do what's inside the parentheses, right? Then it just this second one here has an exponent. We got to take care of that before dividing. All right, so there's no plus sign or minus signs outside the parentheses. So we just have to do the operation within the parentheses. So I'm going to do this one. So remember now, every time when we add and subtract between a whole number and a fraction, we can use that same trick. Now, that same trick with the mixed number. 3 times 2. And now we can minus the 1. 3 times 2 is 6. 6 minus 1 is 5. So what's inside the first parenthesis is really 5 over 3 divided by. So once I figure out what's inside the parenthesis, I just write it. I don't need to put another parenthesis on it. But here though, once I figure out what's inside, I got to square it. Okay, so 1 minus 1 over 3. Same trick. 3 times 1 is 3. And what do I do with the numerator? This time I will what? Subtract, which is 2. So what's inside the parenthesis is really 2 over 3. Now I'm still writing in the parenthesis because I have a square on the outside of it, right? So what does that mean, square? Square means multiply by itself 2 times. So this is really 2/3 times 2/3. 4 over what? Which is 4 over 9. So what's coming out of the second parenthesis, including the square, is 4 over 9. So now this problem becomes division of a fraction. So that means times the reciprocal, 9 over 4. 5 over 3 stays the same. Now I see that 3 and 9 can be reduced by 3. That gives me 1 and 3. My answer, 15 over 4. Okay, so real quick, a couple of things on these homework. So these are the for example, I would like you to try. So this one is like the one we did, okay, just without the exponent. All right, so subtract what's inside the parenthesis first, add what's inside the other parenthesis. Okay, once you find, so you got to find LCD, increase the numerator before you can subtract. Same thing here with the adding, got to find LCD first. Second example, see that plus sign right here? Okay, we can separate. We can actually separate into the division first and multiplication as a separate. All right, this one right here. Okay, this one is a little bit tricky. Okay, remember now, eventually, after I did this, what's inside the parenthesis, I will end up dividing. So dividing by mixed number means I gotta convert everything into improper fraction. So here I would just go ahead and do the little trick, right? 13 times 3 and plus 3. So whatever that is over 13 divided by, okay, go ahead and convert this into a improper fraction. So then we can say times the reciprocal. Okay. All right, this one right here, like earlier, go ahead to find the LCD between all three of them, so you can actually go ahead and once you find the LCD, you can go ahead and increase the numerator and start adding them up. But remember, this answer coming out will be a mixed number, so that mixed number got to be converted into improper fraction before we can say divided by 3/1 means times by the reciprocal. Okay, so I hope that helps, and thank you for watching this video.